So let's talk a little bit about signal flow and latency when you're recording audio. I like to use a metaphor of water systems, and it's something that I picked up from another Berklee professor, and it's a really strong metaphor to help you visualize and remember how signal flow works in your home studio. So first, think about water falling from the sky. Right, that's you singing into your microphone. That's the source, and it runs down the mountain through the cables into a reservoir, which is your audio interface. It's going to collect all that signal and then send it to the filtration center, which is your computer, where you're going to do all sorts of effects processing and filtration of your audio signal. And from there, it flows in an underground pipe system back through to your interface and then out to your monitor speakers, which is the faucet in your kitchen at home. That process can take a different amount of time. That journey isn't instantaneous, right? So sometimes you can experience a little bit of latency as you're recording, and that's actually the signal flow just taking its time getting from microphone interface, computer interface, back to your monitor speakers. And also you have to take into consideration the different places that it stops along the way. You're either going to enhance or degrade that signal flow. In order to combat latency, we're going to adjust the buffer size. The lower that the buffer is, the harder your computer has to work, but the faster the sound is going to get to your ears. The higher the buffer size, the less hard your computer has to work, but the longer that process takes. Setting your buffer size is something you kind of have to do on and off throughout the entire session, depending on what it is you're doing. If you're recording audio, then you want to have the buffer lower because you don't want to create latency or hear latency as you're recording. But if you're just playing back and you're mixing, you might be able to set the buffer size a bit higher so that you can hear everything seamlessly without your computer having to work too hard. And the way you can tell that your computer's working too hard is that you're going to hear digital distortion. Let's create latency and resolve latency. I have an audio track, audio 2. I'm receiving signal from an external interface in input 1, and you can see I'm already metering here. So I'm going to arm this track, and I'm now hearing signal coming in through Ableton. So let's check the mic and see if we've got any latency starting off. Check, check, check. So this sounds pretty good. I'm hearing everything in real time, and this is the optimal condition for recording my voice. Now let's navigate to the preferences menu. And I'm on the audio tab here, and here's where we're going to set the buffer size. So I'm at 128 samples right now. I'm going to choose the highest sample size, which is 2048 samples, and we'll see what happens when we do that. Checking the microphone. That's extremely latent, and it would be almost impossible to record a vocal. So I'm going to adjust this back to 128 samples. And we don't have any more latency. So adjusting the buffer size is going to eliminate any latency. And one thing I really love about Ableton is that we're actually given a scientific cue as to the amount of latency. It looks like at 128 samples, we've got 8.68 milliseconds of latency. And if I go back to that highest sample setting, I've got 95.8 milliseconds of latency, which is considerable. Anything above around 13 milliseconds, a human ear is going to consider as being latent or slightly behind. So just balancing these settings as you move through your session is going to be really important.